Welcome back. We're now going to continue our calculations of probabilities in Excel, and we're going to learn how to calculate percentiles. This is a continuation of the video I posted before this. So if you would like to know how we calculated the cumulative probability function, how we generated the bell curve, please watch the video. I'll insert the link right here. So now let us see how we can find percentiles in Excel and how we interpret them. So in Excel, in order to find, say, the 99th percentile, we can make use of the NORM.S.INV function. So when you open the bracket, it asks you for the probability. So here, since we're looking at the 99th percentile, we're going to insert 0.99. So the value we get is 2.326. Now let us round this up. Okay. So let us see how we interpret this value. This value is your z value. So on your bell curve, 2.3 falls around here. Okay? So what this means is the probability on the left side, or less than the value of 2.3, is equals to 0.99. Now, another way to interpret this is 1 minus 0.99. So the probability on the right hand side of 2.3 is equals to 0.01. 2.3 is then your 99th percentile under the standard normal curve. Now let us examine the probabilities that we generated in column H. So for instance, let us look at when z equals to 1, and let's interpret what these values mean. So when z equals to 1, let me drag my bell curve. So when z equals to 1, 1 is right here. So the value we got when we used the normal standard distribution function in Excel for cumulative probability for z value of 1 was 0.8413. That means that the probability on the left hand side of 1, or less than 1, equals to 0.8413. Another way to say this is 84% or 84th percentile under your standard normal curve equals to 1. Okay. Another example, let's look at 1.7. So 1.7 should be somewhere around here on the right hand side. Again, using our normal standard distribution function, we found the cumulative probability for when z is 1.7 equals to 0.9554. So that means on the left side of 1.7, the area is equal to 0.9554, or around 95.5%. Okay? Another way to say this is your 95th percentile is around 1.7 under your standard normal curve. So going back to the formula again, if we were to use the norm.s.inverse function, and here I put in 0.9554, I should get, if I round this up, 1.7. So this is how we find percentiles in probability using the norm.s.inverse function.